part we need to kind of be focusing on today is, how do I read this? How do I pull the context out of this and say, okay, this is the math I should be doing here. So that's what leads right into the essential question is, how do you tell the difference between a permutation and a combination? How do you tell the difference between a permutation and a combination? No, there is a note sheet online for you guys. It's not a big deal. There's not like a ton of writing, but just something I just had. So here's the notation. Right. So this P parenthesis N comma R. What this stands for is the number of permutations of N elements chosen R at a time. Okay. So the number of permutations of N elements chosen R at a time. So if I was going to say this, that'd be the permutation of 7 elements choose 2, or 7 elements take 2. Okay. Basically what that means is that I'd have 7 things, and what are the ways that I can choose 2 of them, but also including like the order that I choose them matters. What I take first matters, and then what I take second matters. With this notation, we also have this thing here at the very end where R has to be less than or equal to N. Oftentimes in these problems, there's only 2 numbers in the problem. So it's really, can I understand which one's R, which one's N? And we know that R must always be less than or equal to N. Like if I wanted to say, like, I've got 5 students and I want to choose a group of 3, that makes sense. If I say I want to have 5 students, I want to choose a group of 12, it doesn't make sense. So the number that you choose always has to be smaller or equal to the amount of things you have. Okay? So if you only have 2 numbers in the problem, the bigger one always has to be N, or they're the same, then they're the same. Okay? So just a little hint there. So the formula for this math is, so P of N comma R, so the number of permutations of N elements chosen R at a time, is N factorial, which we use a exclamation point to stand for the word factorial. So that's how we say that. We say N factorial. And I'll tell you what that means in a little bit. Divided by N minus R factorial. So there's the formula. Right? It's just a formula. You need to know what N and R are, and then you have a formula. You just plug them in, do the math, boom, you're done. And the calculator will do all that for you. So a factorial is, so if I say 5 factorial, so factorials are only used on whole numbers. We never take like 5.2 factorial is not a thing. Square root of 5 factorial is not a thing. Negative 5 factorial is not a thing. And factorials are only used on whole numbers. What 5 factorial means is 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. So factorial means you take that number that it says, and you take every whole number after it, not 0, every natural number after it, and multiply them together. Okay. So 10 factorial would mean 10 times 9 times 8 times yada yada times 2 times 1. That's what 10 factorial would mean. So 10 factorial, 5 factorial is a shorthand for do all this multiplication. And this should look kind of familiar. We just saw this the other day, right? That on Friday when we were talking about that problem with the people getting in the car, right? 6 people choose 6 seats out of the car. We said, oh yeah, the first person gets 6 choices, and the second person has 5 choices, the third person has 4 choices, fourth person has 3 choices, right? And we went 6 down, all the way to 1. So we saw that math. We wanted to do that math, and we had to sit there and do that math. Well, it gets really annoying to do that if you have large numbers. Okay, so it gets really annoying to write that if you have large numbers. And so this symbol is just used as the shorthand for do that. And then the calculator can then do all of that math for you. Okay, but you gotta know where to find it in your calculator. Okay, so if you have like a TI-30, right? So if you have a TI-30, what you want to do is you hit your 5, and then there's a button up here that says PRB. Okay, anybody got a 30 in here? Yeah. So there's a button over here. And what are you guys at home working with? Maddie, Tiger, Ruthie? Tiger. All right. Well, there's a button up here that says PRB. You hit the PRB button. You bring up a little menu that says there's an exclamation point there. So you go over to the little exclamation point and hit enter. And it says 5, exclamation point, and you hit enter. Okay, so that's where it is on an 83, or a 30, sorry. If you have an 80, whatever. Okay, so you're going to hit 5, and then there's a button on the left side that says math. Oh, you got a 30 there. Did you find it right? Okay. There's a button on there that says math. And then on the math menu, there's a PRB one at the top. It's on the very right. So you hit over and over and over to the right until you select the PRB menu, and then you can see number 4 is the exclamation point. So then it should say 5, exclamation point. Why not? Piper? Calculator? Good? Katie? You guys get home, hey, find the factorial button. So 5 factorial is 120. Okay. So 5 factorial equals 120. Oops. What's 10 factorial equal to? Okay. So you see factorials can get large very quickly. Like we did 20 factorial second hour, and it was like 2 times 10 to the 18th power, like, which is a billion billions. So like, factorials can get very large very quickly. So that's how you find your factorial button, and just in those menus. Okay. So let's talk about how to use it. So I think this is the problem I mentioned yesterday. Pretty classic permutation problem. You have 8 people that enter a race. How do you assign, like how many different ways are there to assign first, second, and third place? Okay. So if if Claire wins first place, and then Piper wins second place, and then Wes wins third place, that's one permutation. Then Claire wins first, Wes gets second, and Piper gets third. That's another permutation. And Wes gets first, and Matt gets second, and Katie gets third. That's another permutation. But then we flip it around, so it's all different permutations. Since who gets first matters, who gets second matters, who gets third matters. Those are all different permutations. Okay. So there's really only 3 numbers in this problem, or sorry, 2 numbers in this problem. There's how many elements there are, which is the 8. How many things do I have? And then how many things am I choosing from them, right? So there would be 8 elements, and then we're choosing or we're taking 3. So it's 8 choose 3 or 8 take 3. It doesn't really matter how you say that. But so deciding that this is a permutation, again, we'll talk about later how we make that decision. And once we know that, which one's N, which one's R. Okay? R is always the smaller of the 2. So if I see 8 and I see 3, R has to be the smaller one, so it's 3. So I would note this as P of 8, choose 3. Permutations of 8, choose 3. Permutations of 8, take 3. Okay? And then we calculate that by saying, well, that's 8 factorial divided by 8 minus 3 factorial. Now, if you're going to type it in like that, of course, those parentheses matter. You can also choose to do that math in your head and say, well, that's 8 factorial divided by 5 factorial. I don't care which one you do. I just generally do the first one, but it's whatever. Okay, they're going to give you the same answer. So what is the permutations of 8 choose 3? You guys should all be practicing this, just like hitting those buttons, trying to eliminate those little button pressing errors you're going to run into as you practice. How many different ways are there to give out first, second, and third medals? 336? So I would like you guys just to add on a little, note, right? Say how many different ways. So you say 336 different ways. Ruth, Tiger, is that what you got? Matt? Caleb, is that what you got? Okay. All right. So how many different officers, president, VP, secretary, could be elected out of this class? So if there's 13 students in this class, and if Maddie, you're president, and Caleb, you're vice president, and Ray, you're secretary, that's one way to elect. But then if Maddie's still president, but Ray is vice president, and Caleb's secretary, that's a different way of getting the election. And Grant's the president, Caleb's still vice president, now Maddie's the secretary, that's a different way. Okay, so the arrangement matters. That they have different jobs, so the arrangement matters. That's a permutation. So we have 13 people, and we're choosing 3 at a time. There's 3 jobs. How many different ways could we assign those jobs? So 13 factorial over 13 minus 3 factorial. What do we get? Claire, what'd you get? 2007-16? That's what I got. You good there, Colby? Katie? Tiger, good on that one? Anything about the math there you guys are curious about? Still haven't talked about how to know which one's which because we haven't talked about combinations yet. So we'll do that here pretty shortly. Let's practice in the math. Okay.
Is it good to have the parentheses at the bottom before you put the factorial next to it?
Yes, you definitely want to have that. If you don't put the parentheses there, it'll do 13 factorial divided by 13, and then you would subtract 3 factorial from that, is what the calculator would think that you're supposed to do.
Okay.
So yeah, you've got to force the calculator to do the subtraction first, or you do the subtraction in your head. So you do 13 factorial divided by 10 factorial. Okay. All right, so very similar notation, right? So we have combination notation. So this would just denote the number of combinations of n elements taken r at a time. And I don't have enough space to write everything I need to, so I'm going to write a red bullet. Without regard to order. Or for order, I guess, better way to say it. Or for order. So there's the difference between a combination and a permutation. With a combination, the order you take the things does not matter. Okay? Just that you end up with those 3 things. So a pretty common way to think about this, the difference between these two things is that this would be a permutation of I have 8 people in a race. I want to assign first, second, and third. Okay. I have 8 people in a heat. The first 3 people get to go to the next heat. Right? It doesn't matter if you're first, second, or third, just that you are in the top 3. So it doesn't matter if it's me, then Grant, and then Wes. It's just those are the 3 people that get to go. Okay. So if the order the things are chosen in doesn't matter, that's a combination. Just that that's the group of things that are chosen. That's all that matters. Okay. Another way to think about this would be to say, hey, I need 3 people to come help me, and Claire, you're going to be my eraser clapper, and Colby, you're going to be my desk wiper, and Caleb, you're going to be my pencil sharpener. Like, oh wait, no. Claire, you're going to be my pencil sharpener. Caleb, you're going to be Colby, you're still be the desk wiper, and Caleb, now you're going to be the razor clapper. So I've just created a different permutation because they have different jobs. Versus if I just say, hey, I need 3 people to come help me. Claire, Colby, Caleb. It doesn't matter if I say Caleb, Colby, Claire. It's the same group because there's no role within the group, no job, no difference in the order that I say them. Okay. So if we create difference in order, or if we create difference in like job/role within the group, that's a permutation. Okay. So if there's some sort of ordering, i.e. like placements, right? If there's some sort of job or role, president, secretary, vice president, that creates a permutation thinking. Okay. If we're talking about just randomly selecting, like all that really matters is like that's the group I get, more of a random selection. That's more of a combination thinking. Okay. So that's how you tell the difference between them. Okay. The math for a combination, so C, the combinations of n elements chosen r at a time is n factorial divided by n minus r factorial times r factorial. So you're going to have a double layer of parentheses when you go to type that into the calculator. If you don't do that subtraction in your head, you're going to need a double layer of parentheses. If you do the subtraction in your head, you'll just need that outer layer of parentheses. Okay. So very similar problem to here. How many different groups of 3 could be made in this class? Well, there's 13 students. Okay. So what's the combinations of 13 choose 3 versus the permutations of 13 choose 3? So the combinations of 13 students just choose 3, doesn't matter what order you choose them in. So that would give me 13 factorial divided by 13 minus 3 factorial times 3 factorial. Again, make sure that outer layer of parentheses is there. And if you're not going to do that subtraction in your head, that inner layer also needs to be there when you type it. So how many different groups do we end up with? Wes, what'd you get? Okay. 36. That's what I got. That's what Bruce got. Good there, Grant? So look how that compares, right? The permutation of 13 choose 3 versus the combination of 13 choose 3. So the idea of adding order to the problem creates quite a few more groups than just the people themselves versus the people being selected in a certain order or being given different jobs. Creates a lot more groupings. Okay? We are going to be working with cards quite often as we do this stuff. So if you don't know a lot about cards, I know that it's just something that's happening more and more. It seems like that you guys aren't growing up playing with cards as much as people in the past. So there may be something that you need to learn real quickly, like how many cards are in a deck, like what the types of cards are in a deck, because we're going to be talking about that quite a bit. So just, if that's something that you don't know, you're going to need to spend a couple minutes talking to somebody about that, figuring that out. It's going to keep popping up. So how many different 5-card hands can be drawn from a deck of cards? So there's 2 numbers within there. Right? They only say 1 number, but there's 2 numbers within there. Okay? And then the idea is that you have your ace of spades, and you've got your 2 hearts, and you've got your 3 of diamonds, and you've got your 4 of clubs, and then you've got your 5 of hearts. But it doesn't matter what order you pick them in, just so that's what's in your hand when you're done. Okay. So that's a combination. The order doesn't matter. So that's why it's a combination. But how many cards are in a deck of cards? 52. Okay. So there's 52 cards. So you have 52 things. You're choosing 5. So how many combinations are that? How many? Just draw randomly. How many different hands are in 5-card hands are in a deck? It's been a little while, but poker used to be a really big thing on TV, and of course there's a lot more to poker than just like pure numbers. But part of it is like understanding these are the cards that have come out already, what's left in the deck still, and those probabilities and combinations and permutations and stuff that are there because of that. So 52 factorial, divide by 52 minus 5 factorial times 5 factorial. And this should be a very large number. What'd you get, Grant?
The number I can't pronounce. 2, 5, 9, 8, 6, 0.
I feel like that's not right. I missed something. $2,598,960. So over 2.5 million hands. It's randomly drawn from a deck of cards. Okay. Again, the math itself isn't hard because you're plugging stuff in the calculator, but how do you make those decisions? Which is this? Is this a combination? Is this a permutation? So that's the next thing I want to talk about, is just practicing that, looking at some situations and kind of reasoning through that. Which math should we use? So we're not even going to do the math. We're just going to say, here's the math we should use and why. Okay? So just looking at some situations saying, here's the math I would do given the chance. Okay. Is there anything on this side you guys want to talk about before we flip over? Just by definition, 0 factorial equals 1. So just FYI, if that pops up, like if you had 5 objects and you're choosing 5, like how many ways are there to take 5, choose 5? Like you would end up with 5 minus 5 factorial on the bottom, which would be 0 factorial. And if 0 factorial equaled 0, which might kind of seems like it would, then you wouldn't be able to do that math. But we know that we can take 5 things and choose 5 of them. That's a possible thing. So in order to make that math work, we had to define 0 factorial to be 1. So it's by definition, not by that it fits the model of everything else, because it doesn't fit the model of everything else. So by definition, 0 factorial is equal to 1. But there's no negative factorials, there's no decimal factorials, there's no square roots. Okay? Everything else is natural numbers. So, all right. Okay, so how many 4-digit codes are possible if no digits are repeated? Is that permutation thinking or is that combination thinking?
Permutation, not repeating digits.
Okay, so Grant's saying that's a permutation because the no repeats. Okay. Other thoughts? Sarah? What do you think? So because the order of the digits doesn't matter? Oops. Make sure I say this the way you said it. The order of the digits doesn't matter, just that they are repeated. Or not repeated. Okay. Different thought. Ruth, what about you? Do you think that's permutation, combination? Why is that? Why is it a combination?
Because the digits are being repeated, so you can combine them however.
So because the digits aren't repeated, then you can just you can put them however you want?
Yeah.
Okay. Katie, what do you think? This isn't about knowing, it's about thinking right now. It's combination, you think it's permutation? Okay. So you're kind of saying like this same thing that Grant said, so permutation because there's no, you don't want them to repeat. Okay. Anybody else got a different thought we need to throw up here as we're trying to figure this out? Definitely got some different thoughts.
I think it would be permutation because if it really didn't matter where any of the numbers went, then you would be able to repeat. Because if you have a 2 in the second spot, it changes what your first, third, and fourth spot would be. So that's my thought.
So you're saying it's a permutation. Because changing one of the numbers would have an effect on the others. Does that sound right, or trying to paraphrase what you said?
Yeah.
Okay. guys are all getting hung up on the wrong thing. This has no bearing on if it's a permutation or a combination. What matters? Order. When you put in your PIN, what are the two things that matter about you putting in your PIN? Go to type in your PIN. What are the two things you have to get right? Order and the numbers. You have to put in the right numbers and they have to be in the right order. Does it matter if the numbers repeat? No. Numbers can repeat, right? But mathematically, all that matters is you get the numbers in the right order and the right numbers. The order that you type them in matters. Okay? Not if they're repeated or not. That will change the math, certainly, but it doesn't change if it's a permutation or a combination. Only thing that matters is that they're in the right order. Okay? So this has to be a permutation. The order of the numbers matters. So make sure you're focusing on the right thing. Okay? How do you tell the difference? Right? Is there an order to the situation? Is there a role or a job that the people have that's specific? Yes or yes, that's a permutation. No or no, that's a combination. Okay? That's the only thing I mentioned there. That's it. And it repeats has no bearing on this, on whether it is one of these guys. It'll certainly change the math. It doesn't take the type of math. That's what we're trying to figure out right now. What type of math should we be doing? Okay. So the next one's kind of like a business idea, like when business makes something, so they would make more than 15 light bulbs. They make thousands of light bulbs, and they go and they grab some to test. Okay, so they test them and see how long do these light bulbs last. Then we can say, okay, my light bulbs last 1,000 hours. So we've tested 100 of them, and that was the average. One of them lasted for 1 hour, the other one lasted for 10,000 hours, averaged out to 1,000. Okay, that's very common idea. You make a bunch of something, you test a small sample of it. Just like when you take a poll, we say, oh, we polled 2,000 people and 300 of them said they weren't going to get a vaccine. Well, that means 15% of America is going to refuse to get the vaccine. Like, you take a small sample, you said, then you can extrapolate that out to, well, here's how the whole population of light bulbs will act. Okay? So we have 15 light bulbs. Maybe to tell them apart, we've labeled them A through whatever, so we know which one's which. How many different ways are there to take a sample of 3? Is that a combination or is that a permutation? Combination, why is that, Grant? Okay. So Grant's saying it's a combo because they're randomly selected. Tiger, what you think?
So, 3, 15 times.
We're not doing math right now. We're talking about which type of math we would be doing.
So,
is this a combination or is this a permutation?
A combination.
Why's that?
Because the order doesn't matter.
Okay, order doesn't matter. All right. Anybody think it's a permutation? Everybody says no. Okay. So if we labeled the light bulbs A, B, C, blah blah blah. So if we picked light bulb A and then we picked light bulb B and then we picked light bulb K, would it be any different than picking light bulb K, picking light bulb E, and picking light bulb B? Would it matter what order we picked them in, or just that those were the 3 light bulbs we ended up with? Order matter? I don't think so. Right? Doesn't say that light bulb A is the one they're going to flick the light bulb on and off real fast, right? And then light bulb E is the one that they just leave on, see how long it takes to burn out, and then light bulb K is the one they drop to see if it breaks or not. Like, it doesn't say anything like that. There's no roll or anything special about which ones are picked. Just here are the 3 that were picked. Okay, so combination. Okay. Basketball tournament, 8 teams. How many games must be played so that each team plays every other team exactly once? Is that combination thinking or is that permutation thinking? Fiber? Which is it? You should know this, right? All that basketball experience? Has nothing to do with the question? What do you think? Permutation, combination? Okay, Piper's saying combination because the order doesn't matter. What do you think, Matt?
I'm thinking the same way.
Same thing?
Yeah.
Okay. Ray, what do you think? Okay, so you feel like the order doesn't matter, but there's something funky going on because you have to play every other team once. Okay. Maddie, what do you think?
I think combinations.
Okay, why is that?
Because it doesn't matter what team plays what team at any time. It's just they have to play eventually.
Okay, it doesn't matter what time they play or like when they play, just that they have to play eventually. So the order. Okay. Anybody think permutation? Anybody think permutation? Claire, what you think? Okay, does that sound right? What I wrote there. You can read that. Okay. Ruthie, Tiger, you guys got anything to add? Colby? What did you think about B, Claire? What did you think about B? Mm-hmm. You agree with that one? So if I drew out light bulb B, wouldn't that then affect like which light bulbs I would have to pick from next? But that it doesn't matter if I pick B, then D, then F, right? If I pick F, then B, then D, right? As long as I have those same 3 light bulbs, it shouldn't matter what order I pick them in. So as long as, if we're team 1, as long as we get to play team 2 and 3 and 4 and 5 and 6, as long as we get to play those teams, like, doesn't matter when we get to play them. Right? Just that we get to play them, right? In the end, we've played all 7 other teams. Didn't matter when we played them, right? Mathematically. Certainly we could add all sorts of layers into this, like, okay, I don't want to play team 2 first because they're like, when they come out fresh, they're a lot of energy and they, we want to play them later when they're tired, or like, we don't want to play team 5 right now because after they played a couple games, they get hot. We want to play them early. So that's a whole bunch of other stuff, right? It's not math. But just mathematically, the order of the team shouldn't matter, just that you get to play all the teams, right? In something like a round robin style tournament, which is what this is implying. So this should be a combination. You guys have by far been the most like in line. All the other classes have been much more on both sides of that. But to me, I would definitely read that as a combination. Because the order you play them doesn't matter. As long as you get to play them. Setting up the schedule, of course, would be important because then nobody would know where they were supposed to go. That's not math. You can use math to set the schedule up, but that desire to have a schedule is not a math thing. That's a psychology thing. All right, last one. How many ways can 4 stockbrokers be assigned 6 unique offices so each broker has a private office? Is this a combo or is this a permute? Permute. What you Matt? What you think? Okay, what's that?
Asking how many ways.
Okay. Okay. So Matt's saying it's permutation because it asks how many ways. More to it, or I'm just trying to make sure I got the right idea down.
Yeah. I think there should be more to it.
Okay. Well, I'll let you ponder that. Let me know if you get something. Wes, what you think? Combination, why is that? Why is that?
I don't see anything.
Okay. So Wes is not reading it as something that where order matters. Order does not matter. Okay. Katie, what you think? We're definitely not in the no phase right now. It's all just about trying to get our ideas out and see what makes sense. What you think? What you feeling? Permutation? Okay, what's that? Okay, so the first thing you said, you think it's a permutation because they're assigned an office, and so that would like kind of matter like which office they're in. But then there's extra offices, so then that kind of makes you think maybe it's a combination. Yeah. Okay, because there'd be 2 empty offices, right? Ruth, what about you?
I think combination because since it just has to be assigned to 6 unique offices, like different ones, then it doesn't matter the order that it has to be in.
Okay, so you're kind of saying the order that they're assigned in doesn't matter. Okay.
Yeah.
All right. Well, I mean, I picked this problem specifically because it's we gotta sit here and talk. Like, why would I do this math versus why would I do this math? And sometimes you can justify both. Like, I really think C is to me is quite clear. It needs to be a combination, and I think B, needs to be a combination. I think A needs to be a permutation. When I read this one, I'm like, I kind of see both ways. Right? But you guys being able to defend like this is why I picked it, and then of course do the math correctly after that is important. I did add a word to this problem to make it go more towards one way than the other. This word here wasn't there in the original writing of the problem. And so I put that in there in the idea that like, well, what if one of the offices was nicer? What if there's like corner offices and then people want those offices? Like we have this desire, like it matters that lawyer A is in this one or stockbroker A is in this one, stockbroker B is in this one, that matters where they are because maybe there's some desire to be in those. And so it's not just purely random which office they get. Right, it may be randomly chosen, but then they're like, well, that's the office I'm in. That's the one I wanted to be in, just like that. I think that adds a layer of like permutationness to it. The other thing that makes me think it's a little bit more permutation-y is that they are assigned an office, and like if you had to make a map of like, hey, here's where this person is, you would need to know where they are. That's like permutation idea. And then if I moved them, that would create a new map. That would create a new permutation. So I think this one hedges towards permutation, but I could definitely see it as being both. So, all right. But you guys do have these assignment down there. It's the same page that was last time, so that's just been posted again. Okay. Otherwise, I'll see you Thursday-ish. Okay.